Hello interwebs, welcome to Let's Fix Computers. I've got a HP here. This is a 15s-fq, 15s-fq, and it's no power. Usual story, there's no light on the charger and the laptop is stone dead. I'm assuming anyway. Yeah, stone dead, no lights on the side, nothing going on. So, let's open this thing up and let's see if we can make it do stuff. So, I'm going to start out by taking off the back cover and we'll do a quick visual inspection and see what we can find. The warranty on this laptop is now void. Unbelievable. Hidden screws because it's a HP. More hidden screws because it's a HP. Ugh. Any explosions in here? Not that I can see, it's pretty clean. Thermal paste has been done at some point. I'm guessing this laptop was refurbished by someone somewhere along the line, hence why it had a warranty sticker on the back of it. Okay, let's just pop that I/O flex out of the way. And probing the DC in jack, we have meg ohms, which is extremely high. That's a bit weird, but it's not a short circuit, so fine. Then I'm going to go straight over to the CPU, and over here we can see CPU vCore, because there's a whole bunch of power stages there. I'll give a close-up of these if we start finding relevant stuff. So there's not a lot of capacitors around here as there normally would be, but all of these coppery looking pads here, let's come down a bit. You can see where there's loads of pads for putting in a crap ton of bypass capacitors here that they've just omitted from the board. Maybe there's some more on the back, maybe they just decided it didn't need them. Either way though, we can still probe these even though they're absent. So black probe on screw hole, and one of these will be ground. Okay, 0.2 ohms, that looks like ground. And the other one should not be ground. Well, that also reads 0.3 ohms. So yeah, it looks like we have a short to ground on the main power rail. My guess is that second one we're measuring is supposed to be the main power rail, because that was a less confident low. You know, like, again, on this one, I don't know, the probing's really weird on these pads, man. I've got very sharp probes on and I'm trying to probe a flat surface, and that can be difficult. Sharp probes, ironically, are better when you're stabbing into solder blobs because you pierce the solder blob. But yeah, I don't know. The point is, I think we've got a... It looks like we have a main rail short here. So let's get the board out of the laptop and we'll take a closer look. Right, roll the intro. Let's do some disassembly. Let's have a look on the back of the board for explosions. Almost nothing on the back of the board at all. Nothing that looks like a failure there. There's a capacitor over here that looks a bit weird. I'm going to take a closer look at that under the microscope. Ah, no, that was nothing. It looked like that capacitor was cracked, but now we're under the microscope. It's just some glue or schmutz on it. You can see a bit of it on that current sense resistor there, so that's nothing. That one there looks slightly spotty, but again, I think that's just a mark. I don't think that's anything. Is that what a dead capacitor looks like? Who knows? Okay. Well, looking around the rest of the board, I haven't seen anything else that looks suspicious to me. Everything looks either pristine or it's got like tiny spots on that could be absolutely anything. I'm going to take off the heatsink. Then we'll probe the other power. We'll probe the secondary power supplies and see if there's anything going on there. We've seen a similar board to this one before. It's a fairly common motherboard layout, and I think the last one of these I was looking at had a dead PCH. So, you know, not holding my breath on this one. Paste needs redoing again. Okay, so we're going to check the secondary power rails. So we're going to check any other inductors we can find, because inductors are for power rails. So we'll just stab all of those and see what happens. So this guy, 7-ish kilo ohms. Okay. This guy down here, 55, 50 kilo ohms, no problem. This guy here, 360 ohms, so 0.36 kilo ohms. Lower, but that's not a short circuit, that's fine. Remember, our main power rail is at 0 ohms, so we're looking for something pretty catastrophic. This guy up here, 140 kilo ohms. Alright. Alright. It looks like we're going to have another case of there's a dead capacitor somewhere on this board. So let's go through the list, everyone. Because we're going to do power injection. And before we do power injection, we've got to do our checklist. So, the problem is we have a motherboard that does not power up. We have discovered a short circuit on the main power rail. So we want to inject power to find the short circuit. So, where are we going to inject power? We're going to inject onto the main power rail, because that's where we have seen 0 ohms resistance, and there should be high resistance there. So we've found a short, we've identified a rail that is at 0 ohms, and it should not be at 0 ohms, and that's where we're going to inject. Are we going to damage anything else when we inject? Well, we've gone through our secondary rails. None of the secondary rails are shorted, so we've no reason to believe that there is a secondary fault that we are going to be passing power into. We haven't checked CPU vCore. Let's come back to that. So we measured our short circuit at the input to vCore, but we didn't check the vCore MOSFETs. So one of these will be ground, 0.4 ohms, and okay, half an ohm-ish, and half an ohm-ish. So there's our short. And if we go over to the other side, so on the other side, we go through these MOSFETs. And at the other side, on this pad, we find... ooh. Half an ohm. Okay, that's not good. That's very low. We're hoping to find... we want to find, like, you know, 4 ohms or a couple of ohms, or just something that's not dead zero, basically. The CPU will be low, but it won't be 0. Let's take a closer look here. We might have a dead MOSFET here that's gone bang, and that means we probably have a dead CPU, which means game over. Right. 0.16 ohms, that's the ground. And 0.3 ohms, that's our short. Okay, good-ish. Probing feels really off today, and I'm not sure what the problem is. And let's check over here again. 0.2, alright. Okay, this is bad. I think we've got a dead MOSFET. I think one of these guys is dead. Let's check over at this one. So these two inductors are on the same output. So this is probably vCore. This is the big heavy lifter. This is going to be a secondary rail. Notice how it's not connected to the same Notice how it's a different one. It's got different MOSFETs on, it's a different inductor, and the output is not connected. So we should find a different reading over here. Which we do. We've got 520 ohms there. Okay, looking at this power stage here, there's like a little dark mark down there, which is a bit more obvious when you look directly down on it, and I'm just wondering if that's where it's like heated up excessively or something like that. So if I had to take a guess, I would say it's this one. I'm going to try hot airing that off the board because I think that's the problem. Right, board is still a bit hot, but let's just do a quick check again. So, fairly certain that is ground. Yeah. And this guy now reads high resistance. So, wah, wah. So, this dual MOSFET is kill. And we can confirm that by checking the back of it. So that's mirror flipped because we've turned it over. So we know that this pad is ground and that comes down and into here. So we know that that is a ground pin. And that, I'm guessing, is the power in. We can check this. If I put my black probe on ground and just check that, that should be high resistance, which it is. So this is our high side. This is our high side input. This is our low side ground. So if we check the resistance through that, no, okay. So we need to go from the drain. Okay, there it is. I'm reading it incorrectly. Yeah, that's a high side short. So this is a dual MOSFET package. It has two MOSFETs in a single chip. The high side MOSFET is going from this top section to the output. And the low side MOSFET goes from this ground to the output, or vice versa, whichever way round you want to put it. So the low side, which is connecting to the output, this guy is fine. It's high resistance, but the high side to the output is shorted. So high side short has put main rail voltage into the CPU. So the CPU is probably dead. Now, at this point, I would normally give up. I'm kind of tempted to just slap I think I have a donor board that is very similar to this. So I might have some MOSFETs that match these. And just for fun, I might just put them on and see what happens. It's worth noting that we would technically need to replace this chip and stuff like that. But I might just YOLO this for fun and see what happens. Let me see if I've got that motherboard. I do. This came out of another laptop with a dead PCH. So the CPU on this one is definitely dead, but it's dead for other reasons, not because its VRM's failed. So these MOSFETs, that's E6936, E6936, oh, GA961L, GA1F25. Okay, they're slightly different, but they're damn close. Like, one of those is the model and the other one is like manufacturing date or something like that. Either way, that's near as damn it. That's probably good enough. What's the driver on this? What are you? 5V8C P6Y. Oh, it's slightly different, but you know what? I'm going to swap the MOSFETs and the driver and see what happens. Okay, I went away to turn on the coffee machine and then forgot to unpause the recording. So I've just removed the driver chip and the other MOSFET from the repair board, and I've taken the driver chip and the MOSFETs off of our donor board here. And so if you're wondering why I've taken all of them off, it's because although only one of the dual MOSFET chips failed, it might have failed because the driver chip has failed. And if the driver chip fails, then it may just jam up with the gate wide open, which burns out the MOSFET. So that's why we're replacing both of them, because the issue is that if we don't replace the driver chip and that's the failure point, then we'll just kill our replacement MOSFET as well. And at the moment, I'm lucky enough to have this donor board, so we actually get a shot at this at all without having to order in parts. However, we basically only get one shot at this because with a probably dead CPU, I'm not ordering parts for this. I would just buy a replacement motherboard. So we're replacing both MOSFETs and the driver chip just because we don't know what the extent of the failure is. And in addition to that, by replacing them all together, we make sure that everything is nice and matched up. It's all supposed to work with each other. So we're maximizing our success chance here. So I'll just put all of that down there. Now we're going to come back in again, and we're going to flow that all onto the board. Here we go. Oh. Oh. Man down. Now I've got to hold the air back a little bit. Okay, one at a time, one at a time. Let's get this one on. I wanted to try and get them all flowing at the same time. Okay, that's not dancing very convincingly. I think I may have needed to wick all these pads down. I tried to avoid doing it, but I think I might have to. We'll check our work in a sec. I think I've got more flux on top of this chip than I have underneath it. Oh, there we go. That just moved convincingly into place. Okay. Driver chip. There we go. Dance for me, little chip. Dance. Now let's just double check that we're not magically shorted to ground again. So that should be ground, which it is. And this should not be ground, which it isn't. Cool. All right. Now I'm going to run the soldering iron just around the edges of that chip just to make sure that those are all good. The bottom, the sides look good. The top needs doing though, I think. So we'll just zip around all of those. Right, I was rudely interrupted by a customer who wanted to give me money. How dare they? But that's good enough. There's still some flux and stuff that I want to get rid of there, but I don't actually think this is going to work, so I'm not going to break my back making it look pretty. Let's just slap the cooler on there and just see if it actually works or not, basically. I mean, I say I'm not expecting it to work. There's a non-zero chance that it's okay because we actually had MOSFETs and a driver for it from another motherboard that's almost identical to this one. So, like, as far as replacing CPU MOSFETs go, after the CPU has taken 19 volts from the charger, you know, like, the odds are not terrible here. But let's find out. Right, I think we've got enough for a test on this, so I'm going to carefully open it up without snapping the hinges because the back cover is off. Try and angle it just so if it catches fire, you'll get a good view. Let's start with the charger. Right, we have a light on the charger. And the power button, I did plug that in. Here we go. We have a power light and we have fan spin. So, okay, power cycled. I want to see the caps lock LED because that will give us blink codes if it's going to do something. No, that's just powered off and stayed off. Okay, hold on. I'll press the power button again. I'm just going to leave it alone and just see if it does anything. No, it just powered off again. I'm going to plug in the chipmunk because the chipmunk will give us some flashes that may indicate some sign of life. So we've got USB power. We're looking for a green flash. No. One more try. No. The chip is burning hot. Kind of seems like it's just instantly overheating. You know, I might actually just put some thermal paste on that. The problem is I don't know if we're just burning out the chip or not. But it wouldn't turn on if there was a power fault, so I don't think that's the case. Burning hot again. No, I'm pretty certain that's dead, Jim. No, the CPU just instantaneously overheats and cuts out. That CPU is dead. I'm calling it. So I did just completely YOLO the driver and MOSFETs there, but they have come off of a virtually identical board. So while the MOSFETs are almost certainly indistinguishable, there's no guarantee that the driver chip is configured the same as our donor board. A resistor here or there could be a different value to set different modes or set voltages. But I think that's unlikely for a motherboard that is this close a match to the original. What's more likely is that the half an ohm of resistance we measured on the CPU means that it's already dead and just sinks any power that our rebuilt VRMs send into it. Either way, it's time to just replace the Mobo. For me, similar or even higher spec motherboards for this chassis are available on eBay for about £100, and we're talking 10th gen i5 boards here, so a second-hand Mobo is an easy fix from this point onwards. Alright, we've got a new board to put in this thing, so let's take a look and just see where I got up to. So, putting in a new motherboard isn't really the superstar repair ending to a board repair video, you know, and it often feels like a cop-out to just be like, just put a new motherboard in it. But when a new motherboard can be as inexpensive as some of these HP ones are, and you're in business and you have deadlines to meet, it just ends up making more sense. And like, don't get me wrong, I do believe in trying to fix a board because a replacement motherboard isn't always easily available. And in addition to that, even if a replacement motherboard is available, if you manage to fix the board, every penny that you charge the customer is pure profit at that point because it's a labor repair. Whereas in this instance, the money that I've spent on the replacement board now basically comes out of my profit margins to an extent, you know. Like, sure, I can charge a little bit more for parts, but the actual profit margin is still thinner than if I had charged less for a board repair that was 100% profit. So it's always going to be preferable to fix the board if you can. But if you're unable to fix the board, or if it turns into a pain in the ass, there's nothing wrong with just putting a new board in. And to boot, the board that I'm putting in is actually a generation newer than the old one. So they end up getting an upgrade at the same time as well. And that's always a nice thing as well, because one of the other things that's always sucky about a laptop repair is that the customer has to pay whatever your bill is just to get back what they previously had. And that's never fun for anyone, you know. So if they're going to pay money, at least they get back something that is better than it was before, which is always a plus. Now I have to remember where any of these screws went. Now we transfer over bits and pieces from the old board. So we've got a Wi-Fi card, which is screwed in really tightly. There we go, one working laptop. So slightly boring end to this repair because it ended up just being put a new motherboard in it. But I hope that was kind of interesting as a diagnostic session, if nothing else. We tried doing some things and it didn't work out, but a replacement motherboard was available and inexpensive. So sometimes the most boring solution might just be the best. Thanks for watching, everyone. I'll see you all next time. Bye.